So, welcome and good morning to day 3 of Advent of Code 2022. Rucksack Reorganization. So, the elves have made a list of all of the items currently in each rucksack, your puzzle input, but they need your help finding the errors. Every item in type is identified by a single lowercase or uppercase letter. That is, A smaller case and A caps refer to different types of items. The list of items for each rucksack is given as characters, all on a single line. A given rucksack always has the same number of items in each of its two compartments. So the first half of the characters represents items in the first compartment, while the second half of the characters represents items in the second compartment. For example, suppose you have the following list of contents from 6 rucksacks. Blah blah blah. The first rucksack contains the items, which means its first compartment contains the items of the first half of the string, while the second compartment contains the items second part of the string. The only item type that appears in both compartments is a lowercase p. The second rucksack's compartment contains the only item type that appears in both compartments is uppercase L. The third rucksack's compartment contains this and this. The only is P. The fourth is only this. To help prioritize item rearrangement, every item type can be converted to a priority. Lowercase items types A through Z have priorities 1 through 26, and uppercase items A through Z have priorities 27 through 52. In the above example, the priority of the item type that appears in both compartments of each rucksack is 16. The sum of these is 157. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of those items? Okay, so we'll just grab the example input and put it into here. And we have the example solution, which is this one. We'll put that into the example check. And we also have my input, which we can get here. So that means for now, I would just start with reading the lines, line in lines, and for each of the strings, the lines, we know the length. Well, we can get our length, and if we divide this length by 2, then if a string has 4 characters, this length divided by 2 is 2, and that means we want to have the indexes 0 and 1 in the first. So this is our start index of second part. That means if we take the line and we want to have a substring, we want to take the substring which is from 0 to the start of the second line, because this is exclusive. Let us check. Yes, it's exclusive. This is the first part. And we'll duplicate this, and we use the start index here. And this is then the second part. So we'll now need to find out which item is in both of those sets, which I would do through, I think I would map the characters. Yes, we should. Can we do a toSet directly? Oh, that's awesome. We just do a toSet. And then we take the second part and do this toSet here. We'll subtract the second one from the first one, which no, we want to take. We'll already use the intersection here. We don't need to do that complicated, because well, we have Kotlin here. So intersect. And let's just put a check here. So if intersect is size 0, otherwise we have an issue here. Pro runtime exception. Yeah, no intersection found is good. Although we want to put this on a separate line, so we have an easier time putting the debugger here. So, and this intersection will now need to prioritize, and this is done with alphabet, which is kind of nice, because what we'll now need to do is we'll say our prior. I just call it, well, how is it, common item? Item is intersect dot first, and we'll now just check if the common item, oh, let's put it, we can just write it like this. We'll take the character caps A if this is smaller or equal to the common item. And the common item is smaller than Z. Well, it doesn't it. Unresourced reference. Yeah, we'll figure that out. This should actually work. And if this is smaller, if this common item is larger equal that, and it's smaller equals Z, then we want priorities to be from 27 onwards. That means we'll take the common item, we'll subtract the A, but we add 27, and for having it in this range, no, this is correct, having it larger than, this was a mistake, larger than A and smaller than small Z, we want to have a priority from 1 to 26, so we'll take this, do it with the A here and add a 1. So we then are up with 1 and 26, and we can then call, in the else case, we throw a runtime exception because we don't like this, and we call this priority, which is this one here. Yeah, Yeah, okay, we just need to write command item correctly, and this is easier. Obviously, we need to put that here as well. Then we have our priority here. And we now would like to sum up the priorities, which we'll just do by... I will just collect them already. Val priorities is a mutable list of int, and we'll just head over here, add priority, and we now want to retrieve the sum, so priorities.sum. We need to return a string for my solution here, so go with that. Check this brace here. All in all, this looks kind of nice. We'll set a debugger here if we are allowed to, and we'll set a debugger here as well. Don't want to run into this. And then let's go for the example. Our example solution is this one, which is correct. Our test solution is this one, which is unchecked because, well, we don't know, and we'll submit it. Okay, well done with the first part. Let's go over to the second one. As you finish identifying the misplaced items, the elves comes to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is only item type carried by all 3 elves. The badge is the only item type carried by all 3 elves. What is if a group's badge is item type B? Then all 3 elves will have the item type B somewhere in the rucksack, and at most 2 of the elves will be carrying any other item type. At most 2 of the elves will be carrying any other item type. Then all 3 elves will have the item B, and at most 2 of the elves will be carrying any other item type. The problem, so I think it's just groups of 3. The problem is that someone forgot to put his year's updated authenticity sticker on the badge. All of the badges need to be pulled out of the rucksack so the new authenticity sticker can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Yeah. Every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item. Yes. So in the above example, the first group's rucksack are the first 3 lines, and the second group's rucksack are the next 3 lines. In the first group, the only item type that appears in all 3 rucksacks is lowercase r. This must be their badge. In the second group, their badge item type must be Z. Priorities for these items must still be found to organize the sticker attachment effort. Here they are 18R for the first group and 52Z for the second group. The sum of these is 70. Find the item type that corresponds to the badge of each 3 elf group. What is the sum of priorities of those item types? So that kind of means we need to group our lines in 3 and then we need to find which item type every elf of those is carrying, and this is then the badge or something like this. At least that's what I understood. And it obviously does it matter? They have R in the top. Yeah. So that Okay, so we'll basically not find the intersection in 1, but we find the intersection in 2. And after we have this intersection, which should only be one character if I have not misunderstood this, then we should basically have that done. So is there the possibility we can take 3 here, right? Take while, take unless, give a group 2, group by. Would really love to get these lines in groups of 3. Let us check if there is a possibility to do that in Kotlin. List 2 groups of 3 elements. No. Yeah. Well, so there is no such thing, such a kind of partition where would actually like to see something like a kind of sliding wind, not really a sliding window, but something like that. So, well, need to do it ourselves. So then we will create a loop, which is a group, and in range of 0, and that's actually a nice suggestion. Line size. This. What will this do? This kind of looks not that bad. For group, how do we write the index loop in Kotlin actually? But I think it is actually range 0 to lines dot size divided by 3. Maybe you don't need to write the val here, but this seems to be from enums, which is kind of weird. Maybe it's that one. Yeah. And then we'll take lines and we'll access it with group times 3. And this is our first one, and we also want to have the +1 and a +2, and we'll just take a list of them so it's afterwards easier to handle. And we now want to go through that list. So do we, or do we just do it like this? It might even be easier like this, yeah. If it's at maximum 3 elves. This kinda makes more sense. We'll just take our elves. Also, we could already operate over this. This would mean, yeah, to set. And we want the intersection with this one, and we want the intersection with this one, and this is our badge, badges. Then we can have another check, badges.size equal 1. That sounds good. And if those badges are, I will just put that into solution 1 here. Not nice. Yeah. Just copy that. So yeah, let's just copy this to here, copy this to here, remove that trash up there, and we now have our priorities. We will get the priority here again, and the common item in our case, well, it's no longer the val common item is badges.first. Badge. Priorities work as they did before. And we now yeah, we should actually be done, if I'm not mistaken. Don't really need this, but it maybe makes debugging easier if we screw it up. And we then take the sum of the priorities. And the range start from start index inclusive to end exclusive. Yeah, that's correct. Is it? I think it is. Yeah, sounds good. I would say we give it a try. Just copy the inputs, P2, add, and we adapt the check, and we want to have the 70 here, and then we go to the main, we have the second puzzle, we'll just run it. This one is correct. Let's see if this one is as well. It is. So, yeah, cool example. I think a little bit, or yeah, obviously harder than yesterday, and also kind of more complex than reading. Thanks for joining in, and see you tomorrow. Have a nice day.